Okay, so we're gonna start circles. So let me give you the intro. You might have gotten this with geometry in your geometry class, but we're gonna cover this right now. So what is a circle? Sorry, wait, move it a little up. You know what? Okay. What's a circle? Sorry. What is a circle? A circle is a set of points equidistant from a fixed point called the center. So over here, I'm going to draw a picture of a circle. So here's the center, and we have a bunch of points that are equidistant. So that's a circle. That's the idea. It's a set of points equidistant from a fixed point called the center. Next thing is a chord. A chord is a segment whose endpoints are on the circle. So here's a point, here's a point. This is a chord. Let's call that AB. So AB is a chord. Good. Next definition, diameter. It's a chord that passes through the center. So here's a chord, here's point CD. The points are around the circle and it passes through the center. So CD is known as a diameter. Next definition, radius. A radius is a segment whose endpoints are the center and a point on the circle. So this is a radius. So let's call this O and let's call this E. So OE is a radius. Now, a lot of kids say, they're like, oh, Mr. Rudlick, a radius is half the diameter, but I throw the example, I'm like, fine, is that a radius? Is that a radius? And they go, no. And I said, well, you said that the radius is half the diameter. So we want a geometric definition of radius, which is we start at the center and go to the point. Yes. Yeah. Yes. The radius is half the diameter. So D equals 2R and R equals D over 2. That's fine. But once again, when you're talking about geometry and things, you want geometric definitions. Good, let's continue. An arc. An arc is part of the circle labeled by its endpoints. I want you to imagine that you have a glass circle and you drop it on the floor. Those pieces are arcs. Okay? And we can see here that I took my circle and I dropped it on the floor and it broke up to little pieces. These pieces are arcs. Now, before we get to the numbers, exactly what is the length of measurement? A semicircle is an arc whose endpoints are the endpoints of the diameter. So, that makes sense. This is, up here, that's a semicircle. It's an arc. It's part of the circle. It's like half the circle. A minor arc is smaller than the semi, and usually it's a minor arc or it's less than half if you see 2 points labeling it. A major arc is greater than a semicircle, and that's generally with 3 points to say like go around the whole circle in that direction. 2 things about the arc. There's 2 things we have to remember. We want the length of the arc versus the measurement of the arc. See me? Yeah. The length of the arc versus the measurement of the arc. The length of the arc is the actual distance around part of the circumference. It's an actual length. Versus the measurement of the arc refers to the part of 360. So, and the best example is let's just take an arc. That's 1/4 of the way around. Right? So let's imagine this circle has a radius of 2 centimeters. So you say, fine, we learned in an earlier geometry class that the circumference is equal to 2 pi r, so it's 4 pi. Now that means the length is pi. because if the full circumference is 4 pi, a quarter of the circle is pi. But we say the measurement is 90 degrees. Once again, the measurement refers to the part of 360. Now we'll start to see a connection here between, yes, we're going to see a connection between degrees and radians, but we're still in 9th grade now. So that's the idea. The length is the actual distance, the circumference. The measurement is a part of 360, or we're going to see part of 2 pi. Okay. Central angle. The central angle is an angle whose vertex is the center of the circle. And you can see I drew a picture over here. I want you to imagine that the rays stop at the circle. So, like, yes, the rays of an angle go out infinitely, but we're imagining that they stop there. And once again, it's all from our trig lessons. Once again, you're supposed to learn all this in geometry. And so we have AB. Let's see, AB, and then we're going to call this part of the circle. This is arc AB, and we're going to use an old word. They don't really use it anymore, but I like it because it kind of helps you understand. We're going to say that this part. We're going to say that arc AB subtends. Subtends. The arc subtends angle AOB. Sorry. So once again, the arc subtends the angle. If you have an angle here, yeah. So the arc subtends it. So an old word, it's just helpful to describe exactly what it's doing. You know, since you're opening the arc. And once again, you're always opening an arc, or the angle is put inside a circle. Okay, last thing. Sector. The sector is the part of the circle that we created with this angle. So the sides are the rays of the angle. The center is the center. It kind of looks like a triangle, actually. So the two sides of the triangle are, the rays of the angle, and then the third side. It's not really a side. Is the arc that subtends the angle. This region is called the sector. Okay, let's continue with circles, and nice. So we drew a, we have a circle, and then we put in a central angle. Sometimes it looks like this. It might look like this. I don't want you to assume that it's always like an acute angle. It could be obtuse. It could be like reflex. So the question I'm going to be asking you is, let's call this AOB. AOB. It's the same triangle. I don't want you to assume that I'm telling you it's an acute angle in here. So let's see. If OB equals 5 meters, and angle AOB equals 60 degrees. Remember, we're in 9th grade still, so we haven't learned about radians yet. We're going to get there. So find what? Find the measure, find arc AB and the area of sector AOB. And it's very straightforward. So, the idea is that the question is, we know that arc AB is part of the whole. So, we know that arc AB is equal to 60 over 360 times, I don't want the whole circumference, I just want that part of the circumference. So, it's 2 pi r. And so the answer is 10 pi over 6 or 5 pi over 3. That's an actual distance, right? So it's it's a little bit more than 5, because 3.14 divided by 3 is a little bit greater than 1, and the little bit greater than 1 times 5 is a little bit greater than 5. That's meters. And then how do we find the area of sector AOB, well, same idea. It's a part of the whole area. So it's 60 out of 360, or 1/6 of the area. Pi r squared. So it's 25 pi over 6 meters squared. This pen is done. And that's basically, and then obviously in an advanced class, I can give you more advanced questions. For example, I might say, oh, I apologize. I might say that, this is example 1. Example 2, I might say, OB is 6 centimeters, and the area of sector, AOB is equal to 12 pi centimeters squared. I'm being nice. I don't have to be so nice, but don't worry about that. And the idea here is you work backwards from the formula. You say, and so I might say, find angle AOB and arc AB. And that's no big deal. You just work, it's just algebra. You're just working backwards. And so, you can say, we can call it theta. And so theta over 360 times, we have the area, so it's pi r squared, and this is equal to 12 pi. And so let's see, we have 36 pi over 360 times theta is equal to 12 pi. And so theta is equal to 360 divided by 3, which is 120 degrees. It's just plugging it in the formula, and then how do we find arc AB? And you say, that's no big deal. So AB is equal to 120 over 360 times 2 pi r. And you're like, yeah, that's 12 pi over 3, which is 4 pi centimeters. And so these are the games you play in 9th grade. So maybe I won't put pi in there. The pi's don't cancel out. And you get these weird numbers, and you have to take, or I might say, I might give you the angle in the sector. What's the radius? And you have to take the square root. That's fine. That's the idea. But let's start to inch our way towards what we did this year, which is we don't talk. Sorry, I'm looking for my eraser. We know that we don't talk in degrees anymore. We're talking in radians. So how do we include that as part of the conversation? Well. So let's take our circle again, right? We have our circle here, and this is theta, and this is r, right? So we know that arc AB is equal to theta over 360 times 2 pi r. And we know that the area of sector AOB is also equal to theta over 360, but this time it's times pi r squared. Well, I'm going to make a little change because I want to bring us closer to our unit, and we're going to call that arc length. We're going to call that S. So we have, this is S. Let's call that this S, right? Well, if you think about this, this is kind of cool, right? Because both of these have pi over 360s. So if I say pi over theta over 360, so for this one, right, over here, I'm going to say theta over 360 is equal to the arc length over 2 pi r. And over here, I'm going to say that theta over 360 is equal to the area of the sector over pi r squared. And that means I can combine these two things together. That means that means the area of the sector over pi r squared is equal to s over 2 pi r. And we get this really interesting formula that the area of the sector is equal to, let's see, the pi goes out with the pi, r squared, and then we have 1/2 SR. And that's kind of awesome if you think about that. The area of the sector is 1/2. It's kind of like the area of a triangle, 1/2 the base times the height. It's not the same, but there's that kind of weird connection, right? That's kind of cool. So, so if you know, if you have the arc length and you have the radius, you can find the area of that sector. It's really awesome. Now let's go into chapter 9. Chapter 9 says what? Chapter 9 says that we define the radian measurement of theta as arc length over radius, right? This is kind of cool. And I'm going to rewrite this, therefore, I'm going to rewrite this formula as 1/2 s times s times r, right? I'm going to put an r up here and an r down there. Because this is times 1. We replace this with, and we get 1/2 theta r squared. So here's another formula for the area. So in radian, now we're in radian worlds. Now we've gone to radian worlds. If you know the radian measurement of theta, the area of the sector is 1/2 r squared times theta. That should remind you of area of a triangle, 1/2 r squared AB sine C. Because the radius are the same length. It kind of should remind you of it. And so these are where the formulas in the book come from. These are where the formulas in the formula book come from. But once again, now we're into, that's the idea. So for example, now this is kind of interesting. If you know, you're given that you have this circle and you know the radian and the radius, you can find, it's easier to find, now it's easy to find all these interesting things. So for example, arc length. So if you're looking for s, you can say, oh, you know what? Pi over 4 is equal to s over 5. So the arc length is 5 pi over 4. You now don't have to go through that major formula. It's much easier in the world of radians because you have the proportion, pi over 4. Also, you can find the area now. The area is now either it's 1/2 pi over 4 r squared, which is 25 pi over 8. So this is what's going on in the formula. So once again, now we're in the world of radians. Okay. Now let's just do the last part of this unit, something else that they're interested in, which is something with sectors. And so my joke is that if you like ice cream, you'll do well with this unit. So what is a sector? What is a segment? Well, IB likes this. It's in the curriculum. You have to know it. How are we doing for time? Good. Good. So here's a circle, right? And we have a sector, right? If we connect the points of where the central angle meets the circle, and we connect that, this region, that's known as a segment of a circle. And so you might say, why do we need this? Well, these problems show up on the test. Well, first of all, how do we find the area of that segment? Well, this is it's like ice cream. The segment of the circle is like the ice cream of an ice cream cone, right? So you're going to take the sector and you're going to subtract off the cone, right? Because I like a sugar cone. I love sugar cones. And that equals the segments. And that's like the ice cream. That's the ice cream. So I could say, the radius is, 6, and let's say that this theta is pi over 6, just to make our lives easier. And so the question is, what is the area of that region? You're like, fine, the whole segment. So you're like, fine, the whole sector is 1/2 pi over 6 times 6 squared. That's the whole thing. But then I want to take away the cone, so you're like, fine, that's 1/2 AB sine of the angle. And when I take the cone away from the entire thing that the person gives you, you're left with the ice cream. So what's the answer here? Well, let's see. We have pi over 12. No, sorry. We have 3 pi. No. Yeah. We have 36 pi over 12 minus, well, sine of 30 is 1/2, so it's 36 over 4. And so we have 3 pi minus 9. And that is the area of the segment. So it's very straightforward. Once again, area of the sector, area of the triangle. Once again, use the 1/2 AB sine C. Now, why am I teaching you this? Because IB likes, the questions IB likes is they put these up. And you're going to think about this on your own. IB will give you 2 circles. So I want you to think about this on your own, and you can come talk to me about this. Let's see, we have 2 circles. And the question is, what is the area in here? What is the area of this region? And I'm going to put the rest of the video on pause. There we go. Okay, let's look at the last part. The last part is these are fun questions, and sorry. The idea is you have 2 circles. Here's center 1. Here's center A, center B, and let's take 2 circles that are the same radius. So circle A has a circle radius that passes through B, and circle B has the same radius and passes through point A. And the question they want to know is something to do with it. Let's assume that circle A and B have the same radius. So what we're interested in is, what is the area of this region? That's the whole thing. And the idea is start drawing in, well, the way the book presents it is start drawing in, triangles. So you're like, fine, this is point A, it goes to the circle. This goes to point A, it goes to the circle. So B goes to the set point on the circle, and A and B, since A and B are on each other's circle, this is also, so this is an equilateral triangle. And the idea is, so this is 6D. That means you did the same thing down here. This is 6D. And the idea here is, so once you have this angle, once you have the angle and you know the radius, you know it's R, this goes back to the ice cream cone. And that's how you solve all these problems. If you think about it, I can just take everything out. I take this out, right? And now I have the ice cream cone here. That's the idea. And so the question is, well, Mr. Arthur, how do you know what part? Well, if I draw a line here, if I draw a line here, I draw a line here, if you think about it, this is my ice cream cone here. This is my ice cream cone, and so half of this is the region that I'm looking for. And that's the point. So the idea here is just find these angles, draw lines in, find the angle. So in this case, let's draw another diagram. So let's do this again. So the idea is, let's say the radius is 4. So I know that this is 4, and this is 4, and this is 120 degrees. So I know that this sector, so what I'm going to do is, I'm going to draw a line down the center, okay, splitting this region in half. So what I want to do is, I want to find the area of my sector and then double that. So what I'm going to do is, I take my ice cream cone, draw it over here, right? So this is 4 for 120, and then I'm able to figure out what this region is. So I have, I can write 120. So the first thing I'm going to do to make my easier, write 120 as a, 3. What is it? 2 pi over, 2 pi over 3. So the area of the sector is 1/2 2 pi over 3 times 4 squared minus 1/2 4 squared sine of 2 pi over 3. And so I have, what do I have? This is let's see, 8. So I have 16 pi over 3. 2 pi over 3, 60, so this is equal to radical 3 over 2. So I minus 16 pi radical 3 over 4. That's this region here. And then I just want to double that. Sorry, I just want to double that. So times 2. And this is the area up here. It's a little tedious. Follow the book. I just want to get you a lesson out. I'll go over it again on Friday. I'll go over it again